Forget about viruses on your phone. Forget about some clever phishing email. We're going to talk about something way more fundamental, a flaw that's baked into the very foundation of the global mobile network itself. This is the story of SS7 and how it leaves billions of us, well, completely exposed.
Look, this isn't a scene from some spy movie. This isn't a hacker tricking customer service into a SIM swap. This is a real, actual capability, and it works by exploiting a flaw built right into the telecom network. It's like a ghost in the machine, and it affects pretty much every single one of us with a cell phone.
And I'm not just here to tell you about the problem. I'm going to walk you through the attacker's entire playbook step by step, showing you exactly how these network commands get hijacked. And you'll definitely want to stick around, because at the end, I'm going to give you 3 specific actions you can take right now to build your defense.
So what is this flaw? I mean, where does it even come from? To really get how the hack works, we first have to rewind the clock and look at a crucial design choice that was made decades ago, a choice that made all of this possible.
This is the key. You have to understand this. Your fancy new iPhone, your secure Android device, it doesn't matter how locked down they are. The vulnerability isn't in your device. It's in the global system that connects everything. This system was designed back in the 1970s, a time when the only people on the network were a handful of giant national phone companies who all trusted each other. And that trust, that's the hole attackers crawl through today.
So, to see how that trust gets exploited, we have to learn the language the network speaks. It's a protocol, and it's called Signaling System 7, or for short, SS7.
The easiest way to think about SS7 is like this. It's the air traffic control system for every single call and text message you send. It's a totally separate network that just hums along in the background, handling all the logistics, setting up connections, tearing them down, handling billing info, location updates, the whole shebang. It's the magic that lets your phone here in the US seamlessly call someone else's phone in, say, Japan.
So when you dial a number, your phone isn't connecting directly to the other phone. Nope. Instead, your carrier sends out these little SS7 messages, basically asking the global network, hey, where is this user right now? The other network answers back with their location, and then SS7 sets up a clear path, a dedicated voice channel just between the two of you. And this all happens in the blink of an eye. It's an incredibly efficient system built for one thing, connecting trusted parties.
And right here, this is the fatal flaw. Because the whole system was built on that old school trust, it doesn't really have strong authentication. If a message comes in that's formatted correctly and it looks like it's coming from another carrier, the network just obeys. It just executes the command. There's no pop-up that says, are you sure you want to forward this person's calls? It just does it. No questions asked.
Okay, so we get it now. The weakness is this baked-in, blind trust. So let's flip the script. Let's put on the black hat for a minute and walk through exactly how an attacker turns this simple design flaw into a seriously powerful surveillance tool.
The very first thing an attacker has to do, the most critical step, is to get a foothold on the SS7 network itself. They need a way to send their own commands into this trusted system. And this isn't something you can just do from your laptop at a coffee shop. It takes privileged access.
So how do they get in? Well, a really common way is to find a small, maybe less secure mobile carrier, maybe in a country with weaker regulations, and just compromise their systems. From there, they can send SS7 messages that look like they're coming from a legit source. But there's an even easier way. They just buy access. Believe it or not, there are companies out there operating in a sort of legal gray area that will literally sell you access to an SS7 gateway.
Once they're in, that's when the real damage begins. The attacker can now inject their own messages into that global trusted network. They're speaking the network's native language.
Now take a look at how easily a normal, legitimate command gets twisted into something malicious. Your carrier uses a command to forward your calls to voicemail when you don't answer. An attacker uses a nearly identical command to forward them to their number instead. Your carrier needs to find your cell tower to connect a call. An attacker abuses that same command to track your location in real time. And the most dangerous one of all, they can just tell the network, hey, from now on, send me a copy of every single SMS message this person gets.
So, with those malicious commands in place, the network is now just obediently rerouting or duplicating all of the target's communications. The final step for the attacker is to just sit back and let the data roll in.
So what do they get? The actual audio from your phone calls. Every single text message. That includes your bank alerts, your password resets, and yep, your two-factor authentication codes. And they get your precise location pinging off cell towers. Let's be really clear here. This isn't just about crooks draining a bank account.
This is a known tool for intelligence agencies to track journalists and activists. This is a weapon for corporate spies. It's surveillance on a massive scale.
And this all happens incredibly fast. We're talking minutes. An attacker with access sends a password reset request for your bank account. The bank texts you the code. The attacker's command intercepts that SMS. You might not even see it pop up on your phone. And boom, within minutes, they're in your account. It's silent, it's efficient, and it's absolutely devastating.
So, this sounds like a huge, gaping, 5-alarm fire of a problem, right? So you have to be asking, why, decades after this was discovered, is it still a threat? Why haven't the phone companies fixed it?
Well, the reality is, it's messy. It's incredibly complex. Trying to replace SS7 worldwide would be like trying to replace the foundation of a skyscraper while people are still living on the top floor. It's this massive, tangled, interconnected system. And yeah, there's a newer, better protocol called Diameter that's meant to fix these problems. But getting every carrier on the planet to switch, that's a multi-billion-dollar, decade-long project for each one of them. So for a lot of them, it's just cheaper and easier to let the old, vulnerable system keep on running.
Okay, that was the problem. And I know it's scary stuff, but I promised you solutions. So now let's talk about what you can actually do to take back control and make yourself a much harder target for these attacks.
Here are the 3 most important things you need to do like today. Think of this as your personal security upgrade. It all boils down to one central idea. You have to move your security off of the phone network and onto devices that you control.
This right here is the single most important thing you can do. Stop using SMS for two-factor authentication whenever you possibly can. Instead, use an authenticator app like Google Authenticator or Authy. These apps generate the codes right there on your phone. The code never has to travel over the vulnerable SMS network. And for your really critical accounts, your main email, your crypto wallet, get a physical hardware key. That is the gold standard. It's basically unhackable by these methods.
Next, be a squeaky wheel. Call your mobile carrier, get to their technical support or fraud department and ask them directly, what protections do you have in place against SS7 attacks on my account? Ask if they can enable stricter filtering or monitoring for your specific phone number. The more of us who ask, the more pressure they'll feel to actually do something about it for everyone. If you remember one thing from all of this, let it be this analogy right here. Using SMS for a security code is like writing your password on a postcard and dropping it in the mail. You're just hoping nobody bothers to read it. Using an app or a hardware key, that's putting your password in a locked safe that only you have the key to. The choice is pretty clear.
And this all leads to a much bigger final question. The SS7 problem shows us exactly what happens when a system built for a tiny, trusted club gets scaled up to a global, untrusted world. It forces us to ask, is the convenience of keeping this old system around really worth the fundamental insecurity it creates for billions of people? That's a question the entire telecom industry is still wrestling with. And frankly, it's one we should all be asking.